Hello, parents and any teachers or students who may be watching. Welcome to Creating Math Ahas. I'm Dr. Sandy Atkins, Sandy, and in this video, we're going to be looking at subtraction in grade 5. Now, there is an intro to subtraction video, and in that video, I mentioned the meaning of subtraction and some key strategies. In this video, we'll look at how those strategies are used, seen in the math that your children do in grade 5. Now, if you want to look at some of the earlier grade levels, you'll be able to see how we use those strategies to do whole number subtraction in grades 2 and 3, how we build that foundation in grades K and 1, and then how we use that for mixed numbers in grade 4, and in grade 5, we'll be looking at decimal subtraction. Now, if you notice, I have some key manipulatives that you'll be seeing today. We have base 10 materials. You may see your children using these or at least pictures of these. If you notice here, I have unit cubes, ones, tens, and hundreds. And then there's a thousands cube. That would end up being 10 of these, okay? Now, I have a paper version made out of centimeter grid paper. The nice thing about this version, unlike this version, if I turn this over, I still see all the little squares. If I turn this over, I now just see the outline of the square. And as we go through this video, I hope you see why that might be important for us to choose to use a paper version versus a plastic version. Now, you also see I have some other outlines of images that become important. One that's divided into tenths, one that's divided into hundredths. Now, as we are looking at these strategies, I hope you'll see that when these materials are selected, it's done very purposefully, and it's done to help build that conceptual understanding that will help your child be both procedurally flexible and efficient. That leads to that procedural fluency. And there's more on that in the 5 strands video, and I'll try to remember links to leave links to those below. So in that intro, I talked about some strategies. One was round and adjust, one was decompose a place, and really one was count up. Now, before we jump into those strategies, there is some foundational work that we need to do with your children. As I said, in the earlier grades, these are introduced to your children to help them get a sense of place value to the left of the decimal point, ones, tens, hundreds. At some point, your children may be asked to think of this as the whole. If this is a whole, this is a tenth, this is a hundredth, so we can change. The problem is when we start to look at fractions and think about the wholes and the parts, we really need to be able to compare same size whole. It has meaning in relation to the whole. So if you notice, same size whole, but I've got here a whole divided into tenths, and here the whole divided into hundredths. Now, before I go any further, I also want to mention that sometimes you'll hear me use the word decimal fraction, and your teachers may use these, make a distinction, decimal fraction versus common fraction. A common fraction are those fractions that when you think of fractions, that's what it is. 3/4, 2/5, 1/8. You might hear the term unit fraction, and those are fractions with numerators of 1, 1/2, 1/3, 1/4, 1/8, 1/10. Decimal fractions are kind of unique in that they're still like common fractions. We can represent them like common fractions. I could represent them as 1/10, something like this. But with decimal fractions, we also write them using a decimal point, and it fits into our place value system. We have 1/100th, I can write it as the decimal version. The key thing when working with your children is try to get them to still read this version as 100th versus 0.01. See, reading it as 100th, 1/10th, 1,000th is really important because that 0.001, 0.01, 0.1 doesn't help us again with the place value ideas. It doesn't help us with the fractions, that size of unit, right? It's just naming symbols. So as you're working with your children, if you can get them to also read this using that fraction, common fraction terminology that we think of, that becomes very important. Now, the difference, decimal fractions are just those fractions where the denominator is a power of 10. 10 to the first, 10 to the second, 10 to the third. Okay, that fits in, as I said, to our place value system. I also want to notice something. Did you notice that I don't have a leading zero? That leading zero is helpful often. So I can put a zero in front of there. It helps me notice that decimal point, but is not mathematically required. Think about typing a number in a calculator. You can type a decimal number into the calculator without going 0.1, right? Normally you would put in 0.27, 27 hundredths as point. The zero, depending upon the calculator display, you may see a zero as the leading number, but you didn't have to enter it. So either one of these would be correct. Okay, I can do it with a leading zero or without. So that's one thing, is for children to really be able to compute, to me, with decimal numbers. We want to also help them build those connections between common fractions and decimal fractions. That this just gives us another way to write it, but we read them the same way. So that's one key piece. So another thing that we want to make sure that the children are comfortable with is the relationship between tenths and hundredths. Now, I know in my early understandings of decimal numbers, I had this idea that you could just throw zeros on the end of that decimal point and it didn't change anything, right? You put the zero on, you put the zero on when you need it. It was great. Didn't change anything. But what we want to make sure children understand is that once you add, and I'll do the leading zero just to make sure we can see, right? When you add that zero to the end, it changes the size of the piece that you're working with, okay? So if I want to look at 3/10, I can color in 3 of these. Hope you can see the shading I'm doing. Yeah. And the key thing is I don't have to do sequential. They don't have to touch each other, these 3/10. I just need 3 of the sections colored in, any 3. Now, when I work with the students, I have them picture this sliding over on top of this. And we color in the same bars, so to speak. So if I slide this over and color it in, do you see how I essentially have the same area colored in? But now this is very obviously 3/10, which I could also write this way. This, do you see how it's same area, but now it's the 30 hundredths. So that's foundational to using these strategies with subtraction with decimal numbers. And I'll give more examples of how we build this foundational idea, how we help your child make connections between tenths and hundredths, pictures you may be seeing and experiences they may have in school in other videos. But I wanted you to see that part of this. Now, the other part that want to think about when it comes to the strategies we're using is helping your child think about decomposing numbers. And you may have seen or heard that term in the objectives for your child, decomposing numbers. Well, decomposing is just a fancy way of talking about breaking things apart, right? We can cut them. Now, remember I told you we will sometimes want to use this version of the model versus this one, because I would be giving your child these base 10 materials and get them used to cutting things. See, I could cut this like this. And if this were my whole equal to 1, equivalent to 1, this would be 70 hundredths. Or written as a decimal fraction like that. And this would be 30 hundredths, written as a decimal fraction like this. Now, if I picture this, this will also be equivalent to 7/10, but 7/10, I'm looking at the whole thing, okay? So 7/10, 3/10. I want to keep this for now as the 70 hundredths, okay? Now, if I want the children to draw what they're doing and draw pictures to show their thinking, drawing a picture showing all of those hundredth pieces drawn in becomes rather cumbersome, right? That is not efficient. And I don't always want to have, or they may not always have, these types of grids to use. We can, it's a way we can look at it, but we can also get them used to thinking about, well, I could cut this. This part is my 30 hundredths. This part is my 70 hundredths. And you see now my picture, instead of having this type drawn or all colored in, I could show, oh, well, there's my whole. I can cut this into 70 hundredths and 30 hundredths. Okay, decompose the whole and think of it in terms of these decimal fractions. So this one, I could use dry erase on this, but when I turn it over, I'm still seeing all of those 100 pieces. Here, I turn it over, I can see blanks. Now this becomes important because I could also cut this something like this. See, what do I have here? Right now I have 97 hundredths. And here I have 3 hundredths. And the problem we're going to look at is, let's do 2 34 hundredths, remove 97 hundredths. So that's why we were looking at that 97 hundredths. Now, one way to think about this, and one strategy that I mentioned in that intro video, is called round and adjust. I'd like you to think about if you go to the store and you buy something that costs 97 cents, right? 97 cents, essentially. I know I have never gone up to the cashier and said, I'm sorry, I don't have 97 cents. I only have $1, 100 cents. Is there any way I could trade you that for 9 dimes and 10 pennies, and then I'll pay you the 97 cents? See, I've never done that. I don't think you have done that. That's not what we tend to do. We tend to go up and remove, right? Give them that dollar and hope they give us back the change. Give us back the 3 cents. For a round and adjust, okay, let's say, I'm going to use these for right now. We've got 234, okay? And I'll go ahead and color in that 34 hundredths. And can we pretend I've colored all of this in? And I've colored all of this in. Okay. Using a round and adjust strategy is what I would do is I would just remove one, but I have to adjust, so I'm going to have to give 3/100 back. Okay. So to remove 97/100, let's look at it again. I'm going to take 2 34/100. I'll remove one, but I've got to adjust by giving back 3/100. Now, see, this takes what for me in school would have been a paper and pencil task. I would have needed to write this vertically. And then I would have regrouped, right? When I was in school, it was called borrowing, but regrouping, you would have seen something like this. And it was about moving ones around. And my mind was not thinking in terms of place value. My mind was thinking in terms of 14, that 4. So now I have 14 minus 7. I have 12 minus 9. I have the 1. It was an algorithm that gave us a way to get an answer, but it didn't necessarily help support understandings of place value and connections to the fractions. So you'll see that your children are learning some of these other strategies because it does help build place value. And it actually has been able to be used with whole numbers, with mixed numbers, now with decimal numbers, these same strategies. And it turns something that was paper and pencil to me into a mental strategy. I can remove one from this and add 3/100 without needing paper and pencil. That's an extremely efficient strategy. So if you think about this, right, I'm going to, if I draw my related picture, right, I have 3 holes, sorry, and in here, I really had, let's see, something that looked like this. This was this was 34/100, right? I had a hole and I had a hole. And essentially what I did was I removed one of these and then I gave back 3 more hundreds. Now, wherever your child colors in, nothing says I had to color in those 300s. I could have colored in 300s wherever I wanted to. Okay, so that would work for whichever one, but essentially round and adjust, remove a hole and give the 300s back. Okay, now another strategy that we were using, one was, let's see, decompose a place. Okay. So essentially, if I'm wanting to remove 2 34, sorry, 97/100 from 2 34/100, I'm going to start a similar way. Right? Let me color in that 34/100 again. Okay. And again, we can pretend that I've colored this all in. Okay. All right. This time, to remove 97/100, I can do a couple of things. I could have thought of this as this version of the whole. Here's 1, here's 2, here's the 34/100. And to remove 97/100, well, I can remove 700ths from here. Doesn't matter which 700ths I remove. I remove 700ths from here. And then see, I think of this as 9/10, because this is my 9/10. I'm thinking of this 9700ths as 9/10 put together with 700ths. I remove the 700ths, and now I need to remove 9/10. So I'm really kind of decomposing this into 9/10 and 1/10, and I can cross that out. I could have done it back on this version, but I decompose it, see what I end up with, right? I can remove by places using place value ideas to remove a whole. Let me see this one again, right? Let me write the problem. We're going to go back to these, right? So I've got 2 wholes, and let's get another 3400ths. See, some of you might have been watching that last video going, oh my goodness, there's a much easier way to decompose that hundredths than the way you did it. You know, that seems hard. The thing is often we set the problem up for your children, and then we say, you remove 9700ths and watch what they do. And that last strategy I showed you is one I've seen children do. Works perfectly, you know, it's perfectly fine mathematically. But see, some of you might have said, well, why don't you just cut it like you showed us earlier? Here's the 9700ths, and here's the 300ths. And if you want to remove it, you just see we decomposed a whole into 9700ths, and let me write that correctly. I bet you all are hollering at the screen again, yes, and 300ths. Now, when I do that, what am I left with? 1 and 3700ths. My picture, here were my 2 wholes. Here's that part I shade in, that's the 3400ths. But how did I decompose this one? 300ths and 9700ths, and cross that out. So decompose a whole, decompose a place, they would have heard earlier, which we're still doing if we think in terms of 9/10 and 700ths. We can decompose a place, but decompose the whole and round and adjust are 2 of those key strategies. Okay. Now, the other strategy that your children are learning, or that I mentioned in that starting video, intro video, was count up. And essentially, we start, it's more of a missing add-end, a think addition approach. So I'm going to connect this starting problem to think addition. How many more than 9700ths is 2 and 3400ths? Now, again, it's important for your children to know not required. Might be helpful for us to notice that decimal point, but not required. Okay. So essentially, what's going to happen here is this gives us our start. We have 9700ths. That's our part. And we can use color to help us know that 9700ths, okay? And the counting up. So here's 9700ths. I'll try to color just a little bit better than I did in the last one. Okay. And my goal is trying to figure out how many more to get me to that 3400ths. So what do? I have 300ths gets me to 1. Then I've got this one gets me to 2. And then I just need to get to 34 hundredths. So essentially what is going in this blank, right, is I've got 3 hundredths, a whole, and the 34 hundredths more. I'm counting up. So I can start, and that's really how we learn to count back change, right? We start with the price of the item, 97 hundredths, and 1 is 98 or 97 cents. I can do, and 1 is 98, 99, $1, $2, and then however I give back the 34 cents, right, to what the person gave me for some reason. That's the counting back change idea, counting up. Now, there's another model we use for counting up that's going to be sufficient, maybe even more. And you may see your children coming home with what is called open number lines. And essentially what that is, if you've seen these, is it's a part of the number line. It's a line segment that's coming off that number line. Now, many of the number lines I remember using in school until I got up into upper grades tended to always have 0 at one end, had all the hash marks there. What this does is gives us more freedom to focus in on key numbers that we want to versus all the hash marks, which for some children leads to them counting everything, right? Versus thinking of jumps and getting to those benchmark numbers. Now, in this case, I'm going to put 97 hundredths at one end and 2 34 hundredths here. And what I'm trying to do is we're going to count up. I want to figure out how far apart these are. See, for me in school, subtraction meant you had to go left. But if I'm thinking of subtraction as counting up, I'm going right. I'm thinking addition to find this. Now, I'm going to redraw this here because when I start to make my jumps, I think I'm going to get into that equation. And I apologize because I know that my drawing will not be to scale, but I hope you'll get the idea. Think about a key benchmark number close to this is 1. So what was my jump? My jump was 3 hundredths, got me to 1. I can do a jump now of 1 to get me to 2. And then I can just do a jump of 34 hundredths to get me up to 2 34 hundredths. You see, every single time it's 1 37 hundredths, well, it better be the answer, right? If I've done it correctly. Now, I've written this with a blank. As your children are going up through the grades, you may see blanks replaced with boxes, replaced with stars, replaced with letters. And especially as they're getting ready for middle school, we're wanting them comfortable with seeing letters for unknowns. Now, notice how I'm calling this an unknown versus a variable. This is an unknown. We're trying to find the one answer that fits in there, right? In this case, A is the same as 1 37 hundredths. I hope this makes sense. I hope you see how we can use some of these strategies that I mentioned in the introduction to subtraction video and have shown connections across the grade level, build right up into your children using them in grade 5 when they're doing decimal subtraction. Again, we're going to turn what is a paper and pencil only task when I was in school to make it a very achievable mental arithmetic task in many cases. So if this video was helpful, please give it a thumbs up. Please subscribe so you know when other videos become available. And thanks so much for watching.